Hello class, it's Mr. Y. Sorry I'm not here. Here's a little robot friend to help me teach this lesson. Today's the 3rd on a Friday. Please copy this down so that we can get started. So after you finish watching this video, I'm going to go through examples 1 through 3. You're going to start to practice, and we could also loop the video if anybody wants to watch this again while everybody else is practicing. If we finish with these problems, I'd like you to complete the problems from yesterday. Okay, so basically we're doing the exact same thing we've been doing for the past couple days. Here's kind of a little graphic organizer to explain all the different things. We have 3 basic forms: standard form, vertex form, and factored form. They're each kind of useful in their own way. So here's example 1. Gotta have our robot friend. Okay, so example 1, this is vertex form. Right here and here, this is gonna be the vertex. So our vertex is 4, negative 18. And in these examples, we're looking for these critical values, and it looks like we've already got one of them. In order to graph this, we're not going to be able to use the normal 10-unit graph, so I'm going to have to go by 2's if I want this parabola to fit. So if I go over 2, 4, I would have to go down to negative 10, 12, 14, 16, negative 18 for the vertex. I know by looking at the leading coefficient that it's going to be opened up, but before I graph this, what I'm going to do is find the x-intercepts and the y-intercept to help me plot those points. I would say the easier thing to find would be the y-intercept, and at the y-intercept you know it's going to look like 0, something, so I'm just going to plug in x equals 0 into this equation. So y equals 2, 0 minus 4 squared minus 18. 0 minus 4 is negative 4 squared minus 18. Negative 4 squared becomes positive 16 times 2 minus 18. This gives me 32 minus 18, and that's going to give me 14. So the y value for the y-intercept is going to be 14. So 0, 14. So I'm going to go up 2, 4, 6, 8, 10, and then 2, 4 for 14. So that's another point I have there. I know it's going to be a pretty skinny graph. So to find the x-intercepts, it's the opposite way around. I need something, 0. So I'm going to be plugging in 0 in for y. So I'm going to get something that looks like 0 equals 2x minus 4 minus 18. Move the robot momentarily. So then I just have to start solving for x. Like I said yesterday, thinking about solving for x, I can do reverse PEMDAS. So doing addition and subtraction first, I can bring this 18 over. So then I would have 18 equals 2x minus 4 squared. No more addition subtraction, move on to multiplication division. I'm going to divide by 2. So I would get 9 equals x minus 4 squared. Moving on to exponents, I would take the plus or minus square root of 9, which would be 3. So then I would have plus or minus 3 equals x minus 4. Adding the 4 to this side, I would end up getting 4 plus or minus 3 as my two values. So my two values would be x equals 4 plus 3 would give me 7, 4 minus 3 would give me 1. So I can graph those. My two intercepts would be at 7 and 1. Here's 1. And my other one at 7, 4, 6, 7. So those are going to be my critical values, and I can go ahead and attempt to draw this graph. It's not going to be the prettiest. Now, if I know that 14 is over here at the y-intercept, I know by symmetry that there's going to be 14 at exactly the opposite side. So I'm going to find that point there just to help me draw the graph. There's example 1. So moving on to example 2, I'm given factored form here, which automatically gives me the two x-intercepts. The x-intercepts are going to be -5 and +8. So down here, x equals -5, +8. So I'm going to go ahead, -1, 2, 3, 4, 5, one intercept, and 1, 2, 3, 4, 5, 6, 7, 8 is the other intercept. Although this is not in vertex form, I know something special about the vertex in relation to the roots. It's exactly halfway in between there. So halfway in between there, if I take the average of -5 and 8, it's going to be right here in the middle. Actually, I'll do this. 8 minus 5 is 3, and the average of that is 1.5. So that's why right here is going to be my line of symmetry right there at 1.5. So for the vertex, I already know that the x value is 3/2. To find the y value, all I have to do is evaluate f of 3/2. So I'll go ahead and do that. F of 3/2, 3/2 plus 5, 3/2 minus 8. So this is where we have to do quite a bit of fractions. I'm going to change 5 into 10/2. I'm going to change 8 into 16/2. So then I would get 3 plus 10 is 13/2. 3 minus 16 is going to give me -13/2. And these numbers are large enough where I would say use of a calculator would be okay. So -3, 13/2, -13/2, give me about 126.75. So as you can see, the vertex is going to be pretty far above our graph, and it should be open down because of the negative coefficient in front. Last thing I'll find is the y-intercept, which you can find by plugging in x equals 0 and then finding the y value. So f of 0 is -3, 0 plus 5, 0 minus 8, which will give you -3 times 5 times -8. I would do -3, -45 times 8 is -40, which would give me +20. So my y-intercept, 0, 120. I know my y values are going to be too large for this graph unless I change the scale of the y-axis. So instead of this being 1, like this one being -5 and 8, I can change the scale to maybe each one of these being 20. So it would be 20, 40, 60, 80, 100 would be here, and then I could easily fit 120 and 126. So if this is 100, 120 would be here, and there's my y-intercept. And my vertex, I could finish graphing this, would be at 1.5, comma 126, which would be somewhere around here. And then using symmetry, I know there would be another 120 at exactly the other side here. And I could finish my graph. Not the best scale, but we get the idea of this. Oops, whatever. So our last example looks daunting because of all these fractions, and standard form isn't always the easiest to work with, but it does give me the y-intercept right away, and the y-intercept being 0, -3/5. So I already know that I can graph this. It's about -0.6-ish. To continue working with this, it's going to be a lot easier if I factor out a 1/5. Notice they all have divided by 5, divided by 5, divided by 5. So I'm going to rewrite this as 1/5 times 8x squared plus 2x minus 3. And this, hopefully I can factor. Factors of 8 are 8 and 1, 4 and 2. Only factors of 3 are 3 and 1. In order to get positive 2x, I could do 4 times 1, 2 times 3, and that would give me 4 and 6. Positive 6, -4 would give me a positive 2. So in factored form, what I'll end up having is 4x, 2x, the 1 being over here, the negative, and the positive 3. So there's my factored form. From here, I can jump straight to the two different x-intercepts. The two roots, they would be from 2x minus 1, setting that equal to 0. And I would have 2x equals 1, bringing over the minus 1 to this side, and dividing by 2. So one of my x-intercepts is 1/2, and the other one, if you can see, the jump would be -3 divided by 4. So let's graph those. One x-intercept at 1/2, the other one at -3/4. To find the vertex, it's going to be a little bit tricky. It's going to be exactly halfway in between these two. So if I take the average of 1/2 minus 3/4, this would become 2/4 minus 3/4, which would give me -1/4, and then half of that would be -1/8. So the vertex would be at -1/8. And for time's sake, I've already plugged it in into the factored form. So then we have -0.625 as the y value for the vertex. And as a fraction, it's -5/8, which is right there, next to the y-intercept. So then I have enough points where I can confidently draw the rest of the graph.